This video is for Combined Science Higher, and these are the predicted topics for the first paper for AQA GCSE Chemistry exam 2025. I will go over all the topics that you need to master in order to get the highest mark in your exam, and I will talk through the different trends in the exam questions and what to expect in the exam this year. So the first topic I'm going to talk about is acid bases and neutralization reactions, because these are very common in the exam, and I've never seen an exam in the first paper without a long question about acid and especially about acids and neutralization. So they like to ask about acid. They might ask you about weak acids and strong acids and diluted acid and concentrated acid. You have to know the difference between these terms. And one of the most common questions as well is the effect of the hydrogen ion concentration on the pH and vice versa. So they like to ask you, if the pH changes, what would be the change in the hydrogen ion concentration, or the other way around. So you need to know how to do this calculation. Also, it's very common to ask you about the indicators. So what to expect the color of the indicator to be when you have an excess of an acid or an excess of a base in your solution. So remember the pH ranges. So if you have a strong acid or an excess of a strong acid in a reaction, then you could have a pH between 1 and 3. If it's a strong base, then you're going to have something between 12 and 14. Remember that if you don't have an acid or a base, if it's a neutral solution, then the pH will be 7. The second topic is the periodic table. You will always have a question about the periodic table. And in this question, they're going to ask you about the trends, especially in group 1 and group 7. So group 1 is the alkali metals, and you need to know the name because sometimes they ask you to name the elements of this group, what they are called, or this group is called. So group 1 is the alkali metal, group 7 is the halogens. They might ask you about the trend in the reactivity, how the reactivity increases as you go down the group 4, group 1, and it decreases as you go down in group 7. And also they like to ask about the trend in the melting point or boiling points for group 7 and for the noble gases or group 0 elements. Remember that the melting point or boiling point increases as you go down because the size of the atom increase and the number of electrons increase. So more intermolecular forces of attraction, more heat is needed to break these forces, so higher melting and boiling point. Sometimes they ask about Mendeleev table as a history of the periodic table. It's not common, it's not in every single exam, but the most important thing that you need to know about Mendeleev table is that the Mendeleev, when he arranged the elements, he arranged them in order of increasing atomic mass, not the atomic number. And he had to switch the position of some of the elements to make sure that the elements in the same group have the same properties. So this is the common question that would come if Mendeleev table is to be in the exam. And then there's the reactivity series. So in reactivity series, you need to remember that more reactive metals will displace the less reactive ones from their salts or from their oxides. There will be a question somehow about reactivity series. It doesn't have to be a long question, but it might be embedded within other questions. They would ask about reactions of metals with acids and water. Remember that reactivity series arrange the metal in order of their decreased reactivity. So the one at the top are the most reactive. As you go down, the reactivity decreases, and the reactivity is related to how easy they lose electrons. So the elements which are above the hydrogen will easily react with acids, while the ones below the hydrogen will not react with acids. And then they're going to ask you, if they ask about this type of reaction, normally they will ask you to write the ionic equation or complete the ionic equation for a certain reaction. And then bonding, this is topic 4. So there will always be something about bonding. Bonding has so many different things that they can ask you about. And sometimes the question is kind of repeated from one year to another, but it's not exactly repeated. It's just the same type of question, but on a different compound. So for example, they usually ask about the dot and cross diagram to draw or complete a dot and cross diagram, either for ionic compound or for a covalent structure. And sometimes if they don't ask about that, they will ask you to explain the formation of a certain ionic compound. This might even come in 2 years in a row, but they're going to ask you to do this explanation for different ionic compounds every year. The melting points of the ionic compounds, simple covalent compounds, including polymers, is very important because they might ask you to comment or to explain why the melting point of this compound is higher than the other one. Remember that ionic compounds have high melting points, covalent, simple covalent structures or semi-covalent compounds have low melting points because of the intermolecular forces of attractions, which are quite weak. And then the giant covalent structures, very common in the exam. It doesn't have to be a big question, but you need to at least to know the basics about diamond, graphite, and graphene. Remember that diamond doesn't conduct electricity and it's very hard and has high melting points. And then graphite and graphene, they can conduct electricity because they have free electrons which can carry the charge. And then fullerene is not a giant covalent structure. It's one of the carbon allotropes. And the most important thing about fullerene is its uses, especially in medicine. And then one of the most common questions in the exam that almost features in every single exam is metallic bonding, metals and alloys. How metal alloys are harder than metals because of the presence of the other element that distort the giant structure of the metal, and also how metals conduct electricity and heat energy because of the free electrons. And then the electric conductivity of metals, of ions first, of ionic compounds, sorry. So ionic compounds do not conduct electricity when solid. They do that when molten or in aqueous solution because there are free ions to move and carry charge. Giant covalent structure, we have graphite and graphene, which conduct electricity because of the delocalized electrons. And of course, metals conduct electricity because of the delocalized electrons as well, while the covalent structure or the covalent compounds do not conduct electricity because they don't have any free ions or ions or electrons to carry the charge. Topic 5 is the exothermic and endothermic reaction, and it's very common in the exam to ask you to calculate the energy change of a certain reaction, whether it's exothermic or endothermic, using the provided bond energy. So they're going to provide you with a table with bond energies and ask you to calculate the overall energy change, or they will have one of the bond energy missing and they provide you with the overall energy change. Remember that the overall energy change will equal the total of the bonds of all the reactants minus the total of the energy of the bonds of the products. And then sometimes they ask you to complete or draw the energy profile for either exothermic or endothermic reaction and ask you to label the activation energy and the overall energy change. Remember that this is exothermic reaction where the energy of the products is less than the energy of the reactants. The activation energy is the difference between the energy of the reactants and the highest point. And then the overall energy change is the difference between the energy of the reactants and products. It's similar to the endothermic. However, in endothermic, we have the energy of the products is higher than the energy of the reactants. The overall energy change for the endothermic is positive. For the exothermic, it's negative value. And don't do this mistake. Remember that the activation energy will be the difference between the energy of the reactants and the highest point here. And then this is the overall energy change, which is the difference between reactants and products as well. Topic 6 is electrolysis, very, very common in the exam. Never seen an exam without a question about electrolysis. And the most common question about electrolysis is electrolysis of aqueous ionic compound. And you need to remember what gets oxidized when we have aqueous ionic compound, what gets oxidized at the anode, and what gets reduced at the cathode, because there will be competition between the hydrogen ions from water and the cation or the metal ion from the ionic compound at the cathode. And if the metal is below hydrogen in their activity series, it's the one that is going to be reduced. If it's above hydrogen, then the hydrogen ion will be reduced to give you hydrogen gas. And at the anode, there will be competition between the hydroxide ion from water and the anion from your ionic compound. Only halogens like only halides like chloride, bromide, and iodide will be be oxidized at the anode when we have the hydroxide. Otherwise, if you have any other anion, then it's going always to be the hydroxide that is going to be oxidized to give you oxygen gas. Remember that water will dissociate to give hydrogen ion and hydroxide ion. This is a very common question in the exam, by the way. Sometimes they ask you about the extraction of aluminium from the aluminium oxide using molten aluminium oxide as a mixture with cryolite. And they might ask you to write the half ionic equation as well for the oxidation and reduction at the cathode and the anode. Topic 7 is the calculation or amount of substance. So there are a lot of calculations in your exams. And the most common questions about calculation would be they ask you about to calculate the mass of a substance in a mixture, or they could ask you to calculate the concentration of a substance in a solution. The concentration will be either in gram per decimeter cubed or mole per decimeter cubed, and they usually will provide you with the mass and the volume. So to calculate the mass, the concentration in gram per decimeter cube, it's going to be the mass provided in gram over the volume in decimeter cube. Usually they're going to provide you with the volume in centimeter cube, so you have to change it into decimeter cube before you do the calculation. Sometimes they ask you to calculate the relative atomic mass using different isotopes and their relative abundance. Make sure that you know how to do this calculation. Sometimes they ask you to calculate the mass of a reactant or a product, and they provide you with the mass of another reactant or product in this reaction. You need to use the balanced equation to calculate the mass of that one. Also, they can ask about you to write the formula of a certain ionic compound and find the ratio of the ion and different ions of different atoms in a certain ionic compound. This will be based on their molar ratio. So usually they will provide you with the molar ratio, and you need to convert this molar ratio into whole numbers and then use this to write the to write the formula of that ionic compound. Sometimes as well, they ask you to calculate the number of neutrons and electrons in an atom or an ion. They will provide you with the atomic number and mass number and ask you to do this calculation. Remember that the number of neutrons will never change whether you have an atom or an ion, but the number of electrons will change. So if the ion becomes a positive ion, then the number of electrons will be less than the number of protons, depending on how many electrons were lost. And if it's a negative ion, then the number of electrons will be higher than the protons, depending on how many electrons were actually gained. And then planning an experiment. Planning an experiment is a definite question in your exam, and you need to be competent in identifying what is the independent variable, what is the dependent variables, and what are the control variables. So the independent variable is the variable that you change yourself. And then the dependent one is the one that changes or that you measure when you change the independent variable. For example, if you are measuring the change in temperature with time, then that means the independent variable will be the time, and the dependent one is going to be the temperature, because you change the time yourself and then you measure the temperature, how it changes with time. And then the control variables are the variables that you have to keep constant all the time during your experiment. So for example, if you are doing something like measuring the change in the temperature with time, using, for example, a certain substance when it dissolves or when a certain reaction takes place, you have to keep in mind that you need to control variables will be the same volume, the same concentration of everything, and the same size for the particles. So these are the control variables that shouldn't change. And finally, remember that you need to repeat the experiment several times and to take the average. Don't just do the experiment one time. So you just say repeat and take the average. And then there are some miscellaneous questions, which are not long questions, but they will be embedded in the questions, like asking you to balance an equation. Usually the equations that come in the exam are quite straightforward and easy, but you need to practice how to balance an equation. They will always ask you to to write the state symbol. Remember that if there is a solid reacting, like if you have a metal, or if you have something that is insoluble, or a precipitate that is formed, it's going to be a solid, so it's S. If you have water as a product or as a reactant, it's going to be liquid. If it's oxygen, hydrogen, these gases, it's always going to be gas. And then anything else that is soluble in water, it's going to be aqueous. The model of the atom, it's not very common in the exam, but it comes sometimes. Usually it's not a long question. Most of the time it's a simple question, multiple choice with 1 or 2 marks. Just make sure that you know the basics of the model of the atom. And then the redox will be embedded within other questions when they ask about the electrolysis, or when they ask about the displacement reactions, when they ask about the reactivity series. So remember, redox comes from oil rig, so oxidation will be the loss of electrons, and the reduction is the gain of electron. When you react a metal with oxygen, it gets oxidized as well because it gained an oxygen. So oxidation can either gaining of an oxygen or loss of electrons, and reduction is either losing of an oxygen or gaining an electron. They will always ask you to write what are your observations from a certain experiment that they're going to provide you with. Remember that the observations are quite easy to write. So these are something like, if there is a gas, then there will be effervescence. If there is sometimes if it's a metal that reacts with oxygen, then there will be heat. Sometimes it will burn with flame. Remember that if there is something that is insoluble and it starts to react, then it will become a change in size. It will reduce in size because it starts to react. Also, one of the observations, so it could be a change of color of the solution based on what has been formed. Usually, if the product has a different color than the reactant, they will tell you. So if it does have a different color, then you have to say that the solution changed in color or become this particular color, the color of the product. If some precipitate is formed, something that is solid, that is insoluble, or if we add an excess of something that is insoluble, one of the observation will be the presence of a solid at the bottom of the reaction vessel.